Welcome everyone to the Carpenter Working Group on February 26th. Let's get started. So looks like we only have one thing on the docket for today. Derek, if you want to talk about this.
Yeah, I published a RFC last week that I wanted folks to get some opinions on. I think, Garvin, you might find this interesting. We have previously, like right now, the upstream Carpenter only calls get instance types basically whenever it needs to get new instance types. But those instance types have offerings within them. And there's no way for the cloud provider to know when the instance types are out of date or the offerings are out of date. So this introduces new APIs to allow the upstream Carpenter to know when to invalidate its own cache. This is useful for like stuff like node overlay, where we don't want to have to reapply node overlays to the new instance types every single time, or have to or for like pricing updates upstream, where we don't want to have to check if every instance type is still the same. I'll let folks read. If there are any questions, let me know.
I guess I think partially know this, but I don't fully know. But like right now, when a ice, like let's say it's like an ice, right? Like the, does the whole cache get rehydrated because it needs to like figure out things? I can't fully remember, or like when like how often we do we turn the cache, I guess, to refresh data for like offerings.
Basically every single time for upstream. For AWS
Okay,
provider, it's a little different because the AWS provider just updates like the one cache entry.
right,
Um,
okay. That's what I was thinking. Like I think it varies based on provider, but now I guess you can be smarter without the provider themselves implementing it right. Okay.
Yeah. And the provider, and this also helps with node overlays specifically because whenever you pull the get instance types, you don't need to reapply every node overlay to the new instance types or check if the instance types have changed first. So you don't need to you can cache them upstream and then actually rely on that cache because you have a quick way to know if it's still valid because you can just say, give me the generation and say, yep, we're still good.
Okay. Yeah, that makes sense.
I brought it up as an RFC to get other provider input as well. So I know, Alex, I sent this to you the other day. If you have comments about how this would affect you guys, let me know. I don't know if any other maintainers at the other cloud providers, but I'll try to find them to reach out once we talk about it.
Like, I haven't had the chance to take a look yet, but one thing I vaguely remember the way we do caching might have some smarts based on the node class, maybe, because selected things on the node class affect maybe requirements or capabilities of the instance types. And I'm wondering if we would be losing any kind of smarts related to caching if the caching moves in the core. But I'd have to think about it. I haven't had a chance to read through this yet.
Sounds good. For what it's worth, the AWS provider also has that same, like if the node class gets updated, we invalidate the cache of available offering types for those node pools or available instance types. And so because you have like your own get instance type generation thing, as long as you know when to invalidate the cache, you could tell the upstream provider when to refresh. If that makes sense.
Right. And I think what I'm trying to say is that we were able maybe to share certain caches if the node classes are the same, right? Because the key for the caching, I think it's the same in the AWS provider, is composed based on things that matter. And if several different node classes, land on the same key, there is certain sharing of the cache values. I don't know if the same capabilities would be available in core or whether it matters.
Yeah, I see your point. So yeah, in that case, the upstream this proposes that upstream basically keeps a cache of every node pool's instance types around. So we would duplicate it for every node pool, regardless of that kind of smart. Like if you know two node pools have different, I will have the same offerings. We don't do that kind of smart stuff upstream. Um,
Does it make sense? I guess like rather than thinking about this from purely like instance type and offering, it seems like the lowest level, which is this instance type and their what they're capable of, don't change because that's from the cloud provider. Does it make sense to completely separate it out that everyone then references like no pull and all its overhead, then that is a separate cache that then reads back on the instance type. Do you know like what is the I guess most expensive thing the cache is caching? And if we can then maybe isolate that so that we don't like reprocess or return because like does that make sense? Like changing
Yeah.
the perspective? Yeah.
So
Yeah.
you're suggesting essentially like a global instance types thing that's not node pool specific. It's like give me all possible instance types for all possible node pools. And then
Right.
you would be able to filter that by node pool because you would expect the instance types to not change all that often.
Right.
Uh, and you'd
And then we
expect the
can add on,
offerings.
yeah. And
Yeah.
like when we constitute like an instance type with offering and overhead, you simply gathers from the multiple different cache that maybe slightly differently managed. That way, each independent thing can update only when they need to, and they get kept at the frequency they need to stay. That's static
What
at.
I'm already what I'm already proposing is we do separate offerings and instance types because
Right,
offerings
right,
do change very frequently from
right,
instance types. So that gets us most of the way there. What I wouldn't know is do some providers have like the scheduling requirements for an instance type in node pool A differ from the scheduling requirements in node pool B in a way that upstream can guarantee? Like
right,
do
right.
providers do like
Yeah. I think,
I
yeah,
don't
I
know
think
if
that might be the case because I think what you're describing would be possible if requirements don't depend on the node pool or the node class. And it's very tempting, I believe we do that. I don't know if AWS provider does that. It's very tempting to reflect certain things that come from node class or node pool in the requirements. I'm trying to think in our case, maybe, the FIPS support setting may be on the node class, but we probably reflect it as a capability of the instance type by recording it as a requirement when we build up the instance type set. In this way, instance types might differ per node class or node pool in the set of requirements. There may be other examples.
I think there's an obvious example I could point to, which is node pool requirements. So if you require node pool A, I think that's in the scheduling requirements for the instance types for node pool A. So we know
Right.
that there are guaranteed to be differences. What I don't know is how if it's just node pool specific ones, we could add them in later. Or if like you're saying there's like node class specific things that like we can only get from the provider. Or if they don't change in predictable ways. I,
It is a hard
yeah.
question because like I'm just trying to tease out like are there things like requirements? Can that be just a separate thing that we can like almost like a foreign table? I mean, that table with foreign keys to like instance type and offering that way, like you can just mix and match requirements without breaking out another instance type in the cache because it has different requirement, and then break out another instance type because there's different overhead. Rather than that, this all the instance type is the same, and then you just kind of joined against the caches for requirements, for no pools, no class, and then do the same for overhead. That way, there is you can reuse the underlying. It's like you can reuse certain aspects, and then aspects that make sense for it to be like tied to no pool can stay that way. And you can just join across the things rather than let's expand it. Because I know that when I was looking at the overhead, some of the expensive things are like requirements because of the way you have to evaluate that. So repeating requirements may not be a good idea for every instance type. Does that make sense? So like we're expanding in that dimension simply because this is the way it is right now. So I guess I'm pushing for like maybe it's worth figuring out. Can we separate it? If not, that's fine. But maybe there's some value in trying to see like since we're trying to reconfigure this and re-architect this, maybe there's value in figuring out if that can be removed out, if that makes sense.
And be able to like build requirements. So there's two concerns. Are you concerned more about the storing of the requirements in memory, or are you concerned about the building them? Because I know like rebuilding requirements, copying them is a very expensive operation. But I think what
Yes.
you saw with your node overlay was storing the requirements was the hard part.
It's both. I think like yeah, storing it is expensive, but then because we're doing deep copy and stuff, and then reprocessing, that's also expensive. Like the CPU was also higher with overlay previously, and memory,
Yeah.
but it was very obvious that memory blew up more than CPU processing.
Yeah. Because with this, the advantage of this way, at least in the short term, is that we can store the modified overlay versions of them ahead of time, which like it
Hmm.
does increase the memory footprint. I don't know if I think we decrease it in other ways, but since you store the pre-applied node overlays, you don't have to do the requirement copying every single time.
Hmm.
So you get like
Right.
the faster, like you have it cached locally, um, which is nice rather than having to
Right.
reapply it.
Okay. Yeah, I mean, I'm not questioning if this fully needs to change, but I
Yeah.
was just asking, like, does it make sense to break out? Maybe it doesn't, in which case that's fine too. Yeah.
Yeah, I'll have to give that some more thought. I think that's a good, I like where you're going with that. That's good feedback.
Yeah. Unfortunately, I haven't looked at this as deeply. So I was like, I think maybe, but I don't know.
Yeah, sounds good. Any other input, questions, feedback?
Great. Thanks, Eric.
Yeah, happy to see this being changed because it was very confusing when I first saw it.
All right. Are there, doesn't look like there's anything else on the list. Did anyone have anything else? Huh? All right. I guess we can just give everyone back 45 minutes then, unless there's any other thoughts, questions, comments.
I just have
Maybe
a
we could take
quick
this
question.
time.
Sure, go
Oh,
for it.
go ahead.
Oh,
No,
I was
you
going to
first.
ask, like, I missed last week, but where are we on the workload aware scheduling? Like, I know upstream is still like at RFC stage. Is there general like design or like progress that we can start in like incorporating, or like it's still very far off? What yeah.
So I can answer that. There's two parts of workload aware scheduling that we're kind of tracking, and that's like supporting the workload specific scheduling, i.e. gang scheduling, like being able to have Karpenter know to like allocate all the nodes in once. And if you can't allocate all of them, like you start getting ICEs or whatever, or like garbage collect those nodes because you're not actually using them for the like atomic. I think Jason's looking into that. And then there's the whole like autoscaler aware scheduling. And I think you can see in the previous meeting there is the link to workload aware scheduling for cluster autoscaling. It's the second one there.
Okay. Yeah.
Um, so with that, there's nothing really for us to incorporate right now. Um, because it's like very, very early on. But if you guys want to give this a read and start putting your feedback in, it's going to be very, very important. Specifically, if you guys are like users of Carpenter and you have like pod scheduling things that we don't do, looking into the third tab here for pod scheduling preferences and um, kind of adding your user stories, commenting on like when you would want. The whole idea is that like the scheduler can make requests to auto scale to say, hey, like I could put it on node A, but I'd rather put it on a node that looks like this. Can you give me that node? And then the autoscaler tries to fulfill that request. And so if you have use cases like this for like spot to OD fallback or like um, not to preempt if you can get a new node, but preempt if you can't, kind of those kind of use cases, please add and make sure they're covered here because that's where things are going to go.
Okay. Thanks. That's exactly. I wasn't sure which one to look at, but yeah, that's helpful.
Yeah,
Thanks.
there's a million. Cool.
Derek, you were going to say something?
Oh, just maybe we could take a look at the EDEs, other RFCs outstanding, take some time to talk about them if folks want to use the time. Otherwise, thanks for coming.
Do you have a link to where they would be?
PRs, or let's do RFCs because it's working group. Um, let me grab a search link for you. Yeah.
I guess, yeah, that one I was gonna, I don't know the authors here, but I think it was part of a different GitHub issue that I told them, hey, cut it RFC separately. Um, I think like at a high level from the previous conversation that we had, it was like we want to wait to tell Carpenter, hey, don't do certain things through external signal. Like, oh, we know that say AC is down. Stop going to the AC, or even just like we are having some issue. We want to lock the world. Don't consolidate. And I think both my team and whoever wrote, I forgot where they're from. We have like a CI system that touches node pools, but then when we lock the world, we can touch the node pools. So it's possible that like a deployment that touches node pool overrides our lock because we turn off consolidation just by saying like, hey, do not, removing like certain fields so that it doesn't consolidate, doesn't expire. It'll be good that if Carpenter can consume a signal saying it's not the cluster's unhealthy, stop. Don't do anything, just leave it, turn off long consolidation without touching the node pools directly, if that makes sense.
Is this primarily for, I know you mentioned zonal outage. Is this primarily for zonal outage or is this more for like a application specific signal? Like
It
my,
it could be, I guess it doesn't have to be zonal. Zonal is one use case, but it could just be like, hey, someone deploys something bad. We want to stop consolidation to keep the cluster stable while we fix that issue. And internally, we call it like a lock where we're like, okay, lock the world. Don't consolidate anything. But right now, that mechanism is like us going through every node flow and just removing all the consolidation lines. But it would be great if Carpenter supports some way of like, hey, hold this endpoint and if it's saying unhealthy, stop all consolidation. A very simple like kind of description of what I think the problem we're trying to like address here.
yeah, I think, yeah, I think that's worth talking about. Um, I know that there's like a lot of short-term workarounds you can do, but having like
Yeah, yeah,
first class support, I understand, might be
right.
nice. Yeah.
And it can eventually expand to like, hey, this zone is out just because there's no realistic way for us to say stop launching in US West 2A because that zone is out. So this signal can then expand to like, oh, this zone is out. Don't do anything there. But for now, it's like, okay, lock the world. Don't consolidate or don't drift or whatever. And then yeah,
Yeah. I think we'll want to target like because zonal outage is more about provisioning, right, than it is about consolidation.
yeah,
Because
for sure.
like
It's
during a
like
zonal
different. Yeah,
outage, yeah.
yeah. It's
But they're
definitely
interesting. They're both
different. Yeah.
useful.
Yes. I guess at a high level is this, we need a way to tell Carpenter some high level don't do X across the entire fleet that it manages, either consolidating or um, provisioning. But we can definitely just concentrate on like don't disrupt when the signal is blah blah blah, and then we can turn to oh don't provision if it's blah blah blah. But the provision I think is a less important story than the don't disrupt anything kind of thing.
Anybody else have any questions or about the issue?
That seems pretty interesting. I didn't know we've talked about the pod disruption schedule. We could talk about it again. Um, what's this? Anyone have any questions, comments about this one?
Okay, what was the gen was sentiment around this? Are we saying like, yeah, generally I think this is this accepted or not yet?
I mean, it hasn't merged yet, so it's not accepted. I don't know where,
Right, but I wasn't sure like if I forgot like if there's like any movement in like, oh, I think this makes sense. And but then we'll just work on the RFP, or it's more like we don't know yet, we'll wait and have more feedback.
yeah, I haven't had a chance to review it in depth personally. I think like in general, we're looking to do more pod disruption controls or like more disruption controls that let people do them like these types of declarative things. The question is like, does this, since this is a pod, since this wants to be a pod specific construct, my main question is like, does this belong here or does it belong upstream? You know, like you can add Carpenter specific pod or controls, but should this just be a PDB feature? Like that
Hmm.
you can say this PDB applies for this budget or for this time. Oh, and because it's like generally I shy away from the idea that Carpenter wants to have super pod specific controls unless they like weigh in on Carpenter decisions like consolidation. So like the choosing to respect PDBs is our way of saying like that's your way of maintaining your availability and stuff like that. We do this kind of stuff for like pod deletion cost to indicate like when we should consolidate one node over another, not like are we even able to consolidate this node right now? Um, I don't know. It's an interesting question. It could live here and then move upstream.
Yeah,
I'd be curious to know what upstream thinks.
I think there was the mega issue for PDP something something. I already
Yeah,
forgot.
a mega issue pod disruption controls. Alice wrote it.
Yeah, I think it captures some of this, but I think that I agree with you that like yeah, this feels like an upstream thing, especially if it's so it's pod specific. But I think the worry here has always been upstream slow.
Yeah, I hear that. Don't get me wrong. I hear that.
Was there any specific RFCs that anyone wanted to go over? Or just keep on going down the list. We're actively working on capacity buffers.
Thanks for coming, Garvin.
Thanks.
We talked about this node overlay DRA extension as well a while back. So don't need to go over that now. Looks like this is the next one, maybe.
Oh yeah, we've been back and forth on this
Oh yeah.
all over the place.
Oh right, it's
I
this one. I see.
There it is.
Took me a little bit.
Yeah, no worries. I think the latest on this was that we would rather get a better signal. Like we would rather push the that node registration is entirely about like the cloud provider latency and push that fully into the cloud provider land where this configurable latency might be on a per provider basis, but we want to see users ensure that kubelet registers right away so that way you get a signal that like then so you can distinguish between registration and initialization. So the node
Mm,
registers like almost as soon as possible, and then you initialize after that to say that like that's when you do all your startup stuff. That way we have a clearer distinction of like boundaries where the cloud providers can then work to lower their registration time by like fixing latency and stuff like that. And you don't have the whole like user induced latency there. But and then users can work to minimize the initialization latency because that's what they own.
yeah, that makes sense.
I don't know if Brandon, you have some thoughts about node registration.
Not Not really. I mean, I have
Just
thoughts,
gonna,
but
if it's
not fully formed. I don't think it would add much to the discussion.
that's fair.
Not seeing any other RFCs that we,
All right, well then let's maybe do EDs, go through tests.
yeah.
Actually, while Ryan's pulling that up, I have a thing I can add to the agenda. I've been thinking about starting a list of like RFCs or not RFCs, but KEPs that like apply to Carpenter and kind of tracking those someplace central within the Carpenter repo that then we can either use for review. I've been bringing a bunch of KEPs lately to be like, hey, this might apply to us, or hey, this might apply to us. But I think it might be nice to like use time like this that we have for spare to like check in with those KEPs and see if there are new ones and stuff. How do folks feel about that?
I like the idea.
That's all the approval I need. I'll add a section to the working group log.
Derek, what do you want to cover with the EDEs? Just ones that are flaky?
Yeah, use this time to look at our flakes, see if anybody has any ideas.
I love the no more lies PR.
Yeah, it's pretty funny.
They're probably not interesting for testing flakes, but
No, no. It is a funny PR though. What's this one? This was the coveralls outage. Let me just go with stuff that's merged into me. Be a bit easier to figure out the flakes.
I think you can go into the actions page and you can filter by what branch it's on. So you could just filter by
Uh,
main. Oh, this was cover lays. That failed.
mhm. Also filter by failing. I wonder if this is because nodes are still from the last testing run.
Oh, that could be. Samuka, got any ideas?
Is this the lake?
Wait, sorry, what was that?
Wait, like is this the static capacity test lake?
Mhm.
Uh, the I see. Okay, it tries to parallelly bring up like all those. I can take a look at this. Does it flake often? Oh, I see. Okay.
Yeah, I mean, my guess be just because it's getting more than 20 nodes, it's just maybe a node exists from the last testing run.
Yeah, it's some concurrency test that's flaking.
Mhm. Another static capacity tester.
I mean, you can put my name on it. I'll take a look.
Oh, same thing happened here. What is the test that runs? See, are they like two of the same or similar ones? Same one. Fails the right timestamps. All right. See it again. Roll logs are a lot harder to read.
Yeah, I was gonna say this is dense.
Yeah. Do we now have the full logs for these EDE tests? Seems like it just starts at 6 minutes 31.
We don't have what?
Full logs. Like when a test fails, I thought we get full Carpenter logs. It looks like it
We
just starts.
should.
Looks like it starts at clusters waiting on sync for 6 minutes 21 seconds. There's nothing before it.
I wonder if they were getting truncated because we're grabbing them
Yeah.
by like.
Yeah, maybe like a tail number of log or something. Huh. Unfortunate. I start looking into this. Did we make change to this recently? Remember it was maybe failing before? Okay.
Yeah, I think so.
Yeah,
I think we
yeah.
deflect these.
Got it.
I mean,
Well,
Nathan, was this one of the ones you looked at?
What's that?
the
Sorry.
the do not disrupt performance test.
Yeah.
Okay.
How long ago was that?
This was 3 weeks ago.
Oh, yeah, that should be a fine.
All right.
That's
Thank you.
All right.
yeah.
Well, if we're looking at test results from 3 weeks ago, then I think we're probably good to move on from looking at
Should be good.
tests.
Yeah.
Yeah. I think the main one was just the static capacity, which I imagine is just because it's running into resources from previous tests. But Smoke, also if you don't get a chance to look at it, I can take a look at it as secondary.
Yep, let me know. I mean, I'm going on call in like a week.
Okay.
I can.
We can look at any issues. I don't think there's been anything recently in Karpenter. I think accelerated hardware ready is one of the conditions we use, right?
I have no idea.
So it is.
Oh, I see the problem.
Yeah. Okay, so it's that seems like more of a NMA side.
Yeah, that's absolutely an anime bug. Mirror issue for them, yeah.
Yeah. Okay.
Okay, we should try to get some eyes on that. Who are the
Yeah,
anime maintainers?
that's a good question. I can track it down.
Like Shiv.
All in favor of closing this one? Derek, I'll probably need you to close it.
Yeah. I mean, does anybody have any strong arguments for this being like a Carpenter problem? Like, don't get me wrong, we could build out like if you've been failing X out of the last Y time, but like the fact that NMA fails with different tests will fail it and cause it to like flap health status seems wrong.
Mm, yeah, I agree with that.
Well, actually, I don't know if I buy that anymore. Because last transition, if they include the which test is failing in the last transition time, or like last transition time might include they're updating the status because a different test
Oh,
failed. And so, okay, this is trickier than I think,
although
right?
I feel like if, oh, I see what you're saying. Like, let's say they have like two tests that run sequentially. The first one fails and then eventually succeeds, and then the next one fails.
Yeah, no, it's more like yeah, they've got multiple different tests that run either in parallel or sequential. And when each individual test fails, they update the condition, the status to say it ready, false, and the reason changes to be like test B is failing. And then
Mm,
it flaps to test A is failing, and then it flaps to test B is failing. And so we just look at last transition time to determine when it last changed, but that shouldn't be when the like true false last changed.
I see.
That
So
that
internally,
should be
Carpenter should,
just when the yeah, I mean, I don't know if we have the right state to be able to say, because I don't really want to track all of these conditions and say, hey, if you're just transitioning, like keep a timer going for when the condition stays false,
mm,
like store the transition time as later. Because otherwise we're right now we're just lying on coop state, right? Like we're just lying on the status and the last transition time, which is nice and clean. But we really want to be able to calculate like false since X time.
yeah.
And the only way to do that is either have NMA not update the description with the individual test that's failing, which feels like an observability loss, or for them to add like multiple statuses for each test, which feels like the wrong
Multiple
answer.
statuses, or maybe just like events, perhaps.
Yeah, yeah. Let's talk it over with the NMA folks.
Yeah.
What I don't know is are there any other conditions that act like this? And this is just like we're going to have to build this kind of automation anyways. If it's just a problem with like the NMA one, but I can imagine
Mm,
the other conditions treating this the same way.
yeah. That's a good point. Seems like a triage needs investigation.
Investigation. Yeah.
Yeah, can link it in chat. Get memberships soon. This one, spot to spot consolidation true by default.
Yeah, so this is feature graduation. We don't have
Yeah,
I don't think we have a roadmap for spot to
no,
spot. There's another issue for node repair as well.
certainly.
I think in general we need to start being better about having like graduation criteria put into the RFCs for features that are promoted or that are like, written as alpha.
Yeah, I agree. This seems like there's two different. There's an asking a question thing. I wonder if there's any other ways instead of a log. Like, would there be an event on the pod?
Sorry, there should be I don't know if we do mark it as an event, but that's where I think we should go with this if we were going to do something. Disruption blocked. We
Yeah,
should actually event
that's
consolidation blocked. I don't know if we do drift blocked.
mhm. That's worth checking it on. I'll double check that. And then as for this, yeah, all right. Double check the drift block after this. All right, seems like this is still needs triage. Decent conversation. This seems like an RFC kind of thing.
Yeah. They want a budget that's cross node pool.
Seems like yeah. Hmm. Definitely the use case in that.
Oh, no, we don't need to support new API for this. This is the issue we're running into here is like Karpenter doesn't select candidates properly, and so it's bad at doing multi-node consolidation when you have partitioned node pools like they do because of the way we do candidate selection. Clayton's been looking into this
I see. So this
from like
lives
a
more internally, for consolidation.
yeah, like we don't we don't need a customer to configure like, oh, this is completely partitioned from this. They already have, they've tainted it. You know what I'm
Mm,
saying? Like we should know that pods from node pool A are mutually exclusive from pods from node B and not consider multi-node consolidation for both of them. You know, like,
yeah.
or we should be better about generating candidates that are more likely to be actually consolidated together, and we should be better about making sure that we're fair. So like there's, this is a known problem. This is just
Mm,
they're proposing a solution.
makes sense. Looks like it is. We're a minute over time. Um, so I'll stop recording unless anyone else has any questions, comments. But I think we just end it here. Cool. Thanks, everyone.
Thank you.
Actually, yeah, if you're still on, I have a question. Where,
For
like,
me,
I know the video goes on YouTube. Do I put it on YouTube?
if we have to, I haven't been.
Okay. I was just wondering because, like, I saw some of them were, and I was like, that is not in a run book, but maybe it
I
just
have no
gets auto
idea.
added somehow.
Maybe we should probably know that.
Yeah, I'll talk about it in stand up as well. Maybe Jason knows. Oh, wait, no, he's out sick. Shoot.
Well, we may never know.
Yeah, sounds good.
Okay. So yeah.